So I had a very pleasant day today, flying. And I'd like to invite Ton Ackermans up on stage, if I might. He was kind enough to put me in his airplane and fly me over the Dutch coast and show me some of the sights. And then we had a very pleasant lunch discussing the need for well-trained software developers and those who know test-driven development and value software craftsmanship skills. And if I got this correct, you are the president of the NSIM group. Is that correct? Good. So now I'd like to abuse you, if you don't mind. If you'll just stand here, this is the reward for doing a favor to me, right? You get to come up on stage. If you will spread your arms out, just like, yeah, you're going to have to hold them there for some time, all right? Now, for the rest of you, imagine that these outstretched arms are the age of the universe. No, not the universe, the Earth. The Earth forms here, and this is today. Where on this outstretched set of arms did the dinosaurs die? Where is it here? Over here? Over, yeah, so, excuse me, I know this is dangerous. No, this one comes out, yeah, okay. Right there. That's where the dinosaurs died. Where did the dinosaurs first appear? Right there. This is about 60 million years right there. There's another 60 million years. They died 60 million years ago. They came on the earth 60 million years before that. Where did life come out of the oceans on this graph? There. There was no life on land until here. Life on earth spans this particular length. But when did life begin in the seas? Here. Life began on the seas 3.5 billion years ago. We have fossils that are that old. Right? And nothing happened. Hold still now. Nothing happened during this period, right? Except, you can put them down. Hold together. Okay, good. Yeah. Don't do me any favors, man. So the talk I want to give today is called The Scribe's Oath. I have it here in my pocket. It's getting a little bit worn. I've given it a few times. Scribes. Let's go back to ancient times. There were a group of people in ancient times, in ancient civilizations, who knew how to read and write. Not very many people had this skill. It was an extremely specialized skill. Most people did not need to know how to read and write. All you had to do was till the fields or harvest the crops or haul rocks from the quarry or whatever it is your job was. It did not require you to know how to read and write. The scribes, on the other hand, that was their skill. They had a literacy that most people did not have. They were able to write things down. Now, in ancient times, they had laws. Laws have to be written down. People need to remember them, and they need to be precise. So when a king made a law, when a pharaoh made a law, it had to be written down. And then if someone broke that law, a scribe would have to read the law to make sure that it was broken. If there were large transactions that were made, some land baron sells 10,000 sheep, A strict accounting of that needed to be made, and so the scribes would write this down. The scribes understood mathematics. They understood accounting. They could do simple and complex calculations. They understood the difference between legal language and non-legal language. They were a set of professionals. Nothing important happened in ancient society without scribes. Nothing could happen without scribes. The scribes were the lubricant of the society. They made things work well. And because of that, they were elite. They were highly regarded and respected. They wore special clothing. They had secret handshakes. They had special social status. A scribe in ancient Egypt, for example, could not be conscripted into the military. That was illegal. Guess who wrote that law? Scribes could not be taxed. We're going to come back to that one. You don't tax the scribes. They were trained from youth. They were the administrators, the managers, and the wise men of the time. They had a culture. Scribes did. It was an internal culture. They had a set of ethics, a set of standards. They had an agreement amongst themselves about how they would behave in order to properly serve their societies. They were disciplined. They were orderly. They were professionals. To give you some kind of a feel for just how disciplined and orderly some of these scribes were, allow me to describe for you the rules that Hebrew scribes used when they were copying Holy Scripture, the Torah. First of all, they had very strict rules about what kind of material they could write these holy words upon. It had to be animal skins of just the right kind of animal. And those skins had to be tanned in just the right way and pounded to just the right thickness and have just the right consistency. And the scribes had the talent to do these things. They had the procedures. They understood how to make the sheets that could be rolled up into scrolls that they could then write their words upon. They understood how to clean them and how to bind them. They had formatting rules, rules that you and I would recognize. For example, they would divide the scripture up into pages, although pages in the sense that you would scroll through a segment, a vertical segment. And then you would scroll again to get the next page and scroll again to get the next page. You did not turn these pages. You scrolled them, similar to a web page now. A page had to be no more than 60 lines long. Where did they get this number 60? They did not have terminals that were limited to 60, but they had this limit of 60. And they could not be any shorter than 48. So a page could be from 48 to 60 lines. What an interesting format restriction for a page. They had to use black ink, and that black ink was of a very special recipe that is now lost. We don't know what that recipe was anymore, but they all knew how to make this ink just perfectly. They had rules about how you wrote, and you'll like these rules. Every word had to be verbalized as it was being written. You could not write in silence. You had to say the word you were writing as you wrote it. There were certain words that were treated specially, specifically the name of God. Yahweh, the four Hebrew letter name of God, the tetragrammation, Yahweh. Before you could write this word, you had to clean the pen and set it aside, clean your body, then come back and write the word. Once you had finished copying a section of the Torah, that section of the Torah had to be reviewed by another scribe. That other scribe had specific rules that they used to check that the copy was made correctly. Those rules included things like they counted the letters on the original document, and then they would count the letters in the copied document. The count had to match. Then they counted the words in both. They had to match. Then they counted the sentences in both. They had to match. Then they counted the paragraphs in both. They had to match. Then they found the center letter of the original and the center letter of the copy. They had to match. So did the center word. So did the center sentence. So did the center paragraph. This is not a CRC, but it is similar to a CRC. It's a checksum of some kind. A document could only have 3 errors. If it had more than 3 errors, it had to be discarded. But it could not be thrown away. You had to put it in a special place because it contained holy words. It could not simply be thrown away. To discard it, you put it in a special clay jar and you put it in a cave somewhere. Fortunately for us, we have found some of those jars in some of those caves 2,000 years later, and we have the erroneous documents that we nowadays call the Dead Sea Scrolls. Now, I want you to keep that in mind as I now describe us. And I'm going to start with us in the 1960s, because what I want to do is describe our social standing, where we stand in human society. In the 1960s, programmers, nobody knew who a programmer was. Nobody knew what a programmer was. How many programmers do you think there were in 1960? Anybody know? A few thousand, perhaps. Let's go back 10 years before that. How many programmers were there in 1950? A few hundred. And when was there just one? What year was it when there was just one programmer? 1946. Yes, well done. And what was his name? Alan Turing. Now, there were other people who have been said to be the first programmer. It is often said that Ada of Lovelace, who now gave her name to the horrible language Ada. I'm sorry, are there any Ada programmers here? Good, it's a horrible language. Anyway, she is sometimes called the first programmer. That's not exactly fair. She did not write code in the sense that you and I might write code. What she did do was fairly interesting. Charles Babbage had given a lecture in English to an audience. A Frenchman had written notes about that lecture in French, and then someone asked Lord Byron's daughter, Ada of Lovelace, to retranslate them back to English. And as she did that, she understood Babbage's mechanism. Babbage's mechanism was a mechanical computer. It was programmed with cards, pieces of wood that had holes in it. It had instructions that you and I would recognize. It had registers that you and I would recognize. It had the ability to memorize numbers. And it had instructions that would be executed in sequence, including instructions that we might consider to be if statements or jump statements. All of those were in existence in Babbage's machine. And Ada understood this, but she understood something else. She understood, and she is probably the first person to understand, that the numbers in this mechanism did not need to represent numbers. They could represent something else. Alan Turing is the first programmer to program an electronic computer that you and I would recognize as an electronic computer. And the electronic computer he programmed was called the ACE, the Automatic Computing Engine, in 1946. This was an extremely unreliable machine made up of vacuum tubes and CRT memory. It had 20-bit words, and it had 1024 of these words. And he would program this machine in raw binary. There were no assemblers, no compilers, no languages. He had to program this in raw binary. Well, actually, he used base 32. And the kind of programs he wrote, you and I would recognize as programs. He had the problem that he wanted to manipulate numbers. But of course, a computer only has integers, especially computers of those days. So he wrote what we would recognize today as the first floating point package. He realized that he needed to be able to call bits of his program and have those bits return. The computer architecture did not allow for this, and so he invented the concept of the stack and the idea of taking the return address and pushing it on the stack. All of these things he invented in 1946. How long did it take before there were two programmers? Not long. Not long. I mean, right? You're one guy and you're sitting there writing all this binary and you say, I need some help with this. So he gets other people to join him, and the number of programmers begins to grow rapidly. But think about it and look around the room as you think about it. There was this moment in time when there was one programmer in the world. How many programmers are there today? It's tough to know, especially, do you count the VBA programmers or not? But the number is probably close to 100 million. Maybe it's not all the way up to 100 million. Maybe it's only 80 million. Maybe it's 120 million. I don't know the exact number, but the number is large. How do you get from 1 in 1946 to 100 million 70 years later? 70 years. How do you get there? What kind of growth curve is that? Is it linear? It's not linear. It was not linear growth, right? It had to be exponential. Okay, so if it's an exponential curve, that means there's a doubling rate. All exponential curves have a doubling rate. And we can calculate what that doubling rate was. It's not very difficult. What is the log to the base 2 of 100 million? Quickly now, come. Log to the base 2 of 100 million, come. Well, 2 to the 20th is a million, and 2 to the 7th is 128, so we will say 2 to the 27th. 27 is the log to the base 2 of 100 million. And if we divide that into 70 years, we come to the startling conclusion that the doubling rate is on the order of 2.5 years. Now, that's probably not fair because Alan Turing was likely recruiting people a lot faster than once every 5 years. So the doubling rate was probably very fast for the first 10 years. And then it slowed down to a more sedate rate of perhaps 5 years. The number of programmers in the world doubles every 5 years. And if that's true, and I believe it is, at least during certain times, then if that's true, half the programmers in the world have less than 5 years experience. And this will always be true as long as we are doubling every 5 years. Half the programmers in the world will have less than 5 years experience. It's a natural result of the growth curve, which puts our industry in a state of perpetual inexperience. People often look around at programmers and say, well, they're all young. This must be a young person's thing. Yeah, old people don't do this. All the old people left. No, we're all still here. It's just that there weren't very many of us to begin with. The social standing of programmers in the 1940s was non-existent. The social standing of programmers in the 1950s was virtually non-existent. No one knew what a programmer was. No one had heard of the term in the 1950s. By the end of the 1950s, some people might recognize that, oh, there's this funny thing that people do called programming computers, but most people certainly never knew a programmer. No one lived next door to a programmer. You didn't go to dinner parties with a programmer. Not in those days. There just weren't enough of us. By 1960, that really had not changed. By the 1960s, there just weren't that many programmers in the world. Maybe there were 10,000. Maybe there were 20,000. Something like that. It just wasn't a very large number. And so most of us didn't know what a programmer was. There was no social standing. Although there was recognition. The first computer science degree program began in the 70s. Oh, there were guys working on it in the 60s, but degrees weren't offered until the early 70s. What did all those early programmers do? How did they learn programming? Before there were degree programs at university, before you could learn programming at university, where did you learn programming? Where did those early programmers come from? They did not come out of university. They couldn't come out of university. There was no university that could teach them this. They came out of industry. They had to come out of industry. If a company had a computer, the company had to have people to program that computer. Who would they get to do it? Well, they would find other engineers and other mathematicians and other scientists and people who had been around for a while, people who had already understood the business, already understood professionalism and ethics. And they would ask them, could you learn how to program this machine? And these people who were in their 30s and 40s and 50s were the first programmers. When did it change? When did programmers start to be in their 20s? Well, it didn't change in the 50s. It didn't change in the 60s. It changed in the 70s. In the 70s, hordes of programmers poured out of university and were eagerly gobbled up by industry because there is one fact about software developers: there are never enough of them. Except in the year 2000, we had too many then for 2 years. But other than that, our world has always suffered a lack of computer programmers. The demand is always too high, the supply is always too low, which is why we're doubling every 5 years. In the 70s, parents began to think that it was a good idea for their children to become computer programmers. It was a career that could be lucrative, as many of you have discovered. It is a career that was thought of as a good stepping stone into management, a good stepping stone into a much better career. There was also a stigma about being a programmer in the 70s. If you were a programmer in the 70s, you probably got beat up in high school. You were one of those nerdy kids that didn't go out for sports and didn't do all the things that all the other kids did. You were one of those mathy-oriented guys who thought about weird things like computers, and the jocks would beat you up every once in a while. In the 70s, we would have been the strange kids that went to the video store arcade where all the video games were. We were those kids that were playing Pong all the time. Does anybody remember the movie War Games? Okay, that would have been the late 70s. And that young man, I can't remember his name now, the actor, but that young man was painted with a generous light as a nerdy little kid who set the world on fire. By the 80s, the world thought of us as mousy people eating Twinkies, drinking caffeinated soft drinks, and living in our mother's basement while we wrote tons and tons of code. Right? There was not a good attitude towards us. They had a stigma. Does anybody remember Jurassic Park? In fact, Jurassic Park was the first time that a programmer became a villain. Dennis Nedry, the villain programmer of Jurassic Park, the unscrupulous smuggler of DNA who got eaten, his just reward being eaten by a dinosaur. Prior to that movie, if programmers were shown at all, they were shown as ancillary, background, unimportant. Prior to that movie, the computers were the stars. Remember 2001. Can anyone name the programmer of HAL? Dr. Chandra, who made a big appearance in 2010, the movie. But in 2001, you never saw Dr. Chandra. You just knew about HAL. And anybody remember the lovely movie, The Forbin Project, where two computers vie for control over the whole world? Guardian and some other one, I can't remember. And eventually they enslave all of mankind. The computers were the evil ones. If the programmers were there at all, they were trying to pull the plug on their creation. In the 90s, the programmers had become the villains. By the 2000s, the programmers had become everything. Remember The Matrix? That was all about the programmers. Neo was a programmer. Trinity was a programmer. These were all programmers. And not only were they programmers, they were superheroes. Towards the end of the horrible, horrible third Matrix show, you realized that Neo was actually Christ. So, it just went wrong. The whole thing went wrong. Terrible. 2010. I am probably 2012, 2013. I am sitting in Stockholm at a bar outside. I had just been to visit the Minecraft guys at Mojang. This is probably actually 2015. And we're just sitting out there drinking a beer. I'd been giving them lectures all day, and up runs this kid, this little kid, maybe 10 years old, maybe 12, little boy, and he runs up to the beer garden where we're sitting, and he points at one of the programmers, Jeb, and he says, "Are you Jeb?" And Jeb, and if you follow Minecraft, and if your kids are playing Minecraft, they know who Jeb is. And Jeb looks at him with kind of a sigh. "Yes, I'm Jeb." This happens to him all the time. "Will you sign my autograph?" Programmers had become children's heroes. Our children want to grow up to become programmers one day and build something like Minecraft. Our status in society has changed remarkably. Everyone knows a programmer now. Everyone lives next door to a programmer now. Probably lives next door to more than one programmer now because there are just so many of us. But in 2015, we took another step. We graduated one further rank. The day that the CEO of Volkswagen North America, testifying before the Congress of the United States, blamed a couple of software developers for lying and cheating in their code for whatever reason, quote unquote. We had elevated to the highest rank of society, a political scapegoat. Now, the thing about that is that it was a couple of developers who did that. It was developers, programmers, you and I, people in our society, people in our industry, our brothers wrote code that lied and cheated and emitted pollutants into the environment. Those programmers violated a code of ethics that does not exist. We don't have that code of ethics. We need it, but we don't have it yet. Those programmers should no longer be allowed to be programmers. You and I should have a mechanism to say those people should not be programmers anymore because they lied and they cheated in their code. Now, you might say, well, come on, those guys really didn't even know what they were writing. Right? And there was requirements that were handed to them. They just wrote the code. It really wasn't their fault. Sure, I buy that, right. If on test stand, then don't emit. I believe you. Software, this thing that you and I do, is a kind of literacy. We know how to read and write, a special kind of language, a special kind of expressiveness. Most people don't have the need to have this kind of expressiveness. Most people live their lives fine without ever knowing what code is or looking at code. They don't want to see the code. They don't need to see the code. They have lives, they live them normally. You and I have this special literacy that no one else has. And nothing happens in our society without us. That did not used to be the case. It used to be that you could get into your car and drive to the store and no software would be involved. You used to be able to go to the store and buy groceries and no software would be involved. It used to be that you could make a telephone call to your mother and no software would be involved. But those days are gone. Because now there is nothing you can do in our society unless software is involved. Your grandmother interacts with a software system virtually every minute of every day because there is nothing she can do in our society if it does not somehow involve a software system. You can't drive a car without software. You can't make a phone call without software. You can't put something in the microwave oven and cook it without software. You can't start the dishwasher without software. You cannot adjust the thermostat without software. You can't go to the store. You can't buy anything. You can't sell anything. You can't get an insurance policy. You can't file an insurance claim. You can't make a law. You can't enforce a law. There is nothing you can do in our society without a software system controlling and mediating that activity. We rule the world. We do. Other people think they rule the world, but then they hand the rules to us. And we write the rules that execute in the machines that govern everything. And so now it's time to talk again about that tax issue. The dependence of our society upon software is not something that our society actually understands well yet. It is actually not something that you and I understand well yet, because you and I are just doing our jobs. We're just writing code. Somebody wants the code, we write the code. It has not yet quite dawned upon us or upon society that we are at the root of everything. Eventually, society will come to this knowledge, and it will come to this knowledge most likely through an event. And that event will be some poor idiot programmer doing some stupid thing that causes 10,000 people to die in one shot. Boom. And it's not hard to imagine what that might be nowadays. An accident, a software accident, a missing comma that kills 10,000 people. And when this occurs, and it will occur, you know it will occur. Software is already killing people in the hundreds. Just a few more orders of magnitude to go. When this occurs, the politicians of the world will rise up, as they should, in righteous indignation, and they will point their finger squarely at us. And you might think, oh no, they're not going to point it at me. They'll point it at my boss. They'll point it at my business. Nope, the CEO of Volkswagen North America clearly showed what was going to happen when the finger pointed at him. He pointed it down to us. So the finger will come to us, as it should. It is our fingers on the keyboards, after all. And the politicians of the world will ask us the question, how could you have let this happen? And we have to have an answer for them. Because if our answer is, oh, well, my boss told me it had to be done by Tuesday, if that's what our answer is, then the politicians of the world will shake their heads sadly and moan on about the disarray in the software industry and the chaos, and they're out of control, and they will pass laws. And those laws will be what languages you can use, what processes you have to follow, what signatures you have to obtain, what courses you have to take, what books you have to read, what frameworks you can use, and we will become a deeply regulated industry. This is something I would like to avoid. Not the regulation. The regulation is going to come, whether we like it or not. I would like to avoid government deciding what the regulations are. I want to get there first. I want to be there with the regulations so that when the politicians point their finger and ask us how this could happen, we can answer and say, look, this was a terrible accident, but it was not due to our negligence, because here are our standards, here is our ethics, this is how we enforce it. And if we can say that credibly, then perhaps we will avoid the worst that the politicians could do to us. Other industries have done this. Doctors did this. They policed themselves long before their rules were turned into laws. Accountants did this. Architects did this. Many industries have gotten to it first. And then, after the fact, government said, well, we should turn that into law. And so I'm going to propose to you an oath. The programmer's oath. Although lately someone said it should be called the coder's code. It reads as follows, and I submit it to you in all humility. Think about these words, think about these promises, see if they make sense to you. See if it's something that you could promise as a professional. A professional promise is a promise that exceeds the authority of your employer. So if you make the promise, it does not matter what your employer tells you to do if it violates the oath. In order to defend and preserve the honor and profession of computer programmers, I promise that, 1, I will not produce harmful code. What does harmful mean? I think every person has to make that decision for themselves. Some of us might consider weapon systems to be harmful. Some of us might consider weapon systems to be very beneficial. But whatever your view on that is, you would hold it as part of your oath. Harm is something that a software developer does when they release a defect. A defect harms the company that they've written that code for, and the users of that code as well. But defects are not the only kind of harm. There's another kind of harm, a much more insidious kind of harm. Programmers cause harm if they damage the structure of the code, if they make the code harder for other programmers to understand and change. The word software is a compound word. The first word in that compound word is soft, meaning easy to change. Software was invented so that we could easily change the behavior of our machines. That is why software exists, so that we can easily change the behavior of our machines. To the extent that our software becomes hard to change, we have violated the very reason that software exists. Software is supposed to be easy to change. And therefore, anything a programmer does that makes that software hard to change is harm. And you must not cause harm. 2, the code that I produce will always be my best work. Ooh. Really? Yeah, really. I will not knowingly release code that is defective either in behavior or structure. You should be able to go home every night and look yourself in the eye and say, I did a great job today. You should never have to go home and take a shower. And you know exactly what I'm talking about. 3, I will provide with each release a quick, sure, and repeatable proof that every element of the code works as it's supposed to. A quick, sure, and repeatable proof that the code works as it is supposed to, otherwise known as tests. Where did we begin to think that code should not be tested? When did that occur in the last 70 years? When did we begin to shirk the responsibility of making sure that every if statement executes properly, that every while loop terminates properly, that every exception is thrown at the appropriate time? When did we decide that it's okay if some of that code doesn't work? It is not okay if some of that code doesn't work. And so, you should provide proof, quick, sure, and repeatable proof that the code works as you believe. Now, we're all human. We all make mistakes. It is not possible to achieve perfection, but it is always an error not to try. The idea that we will simply accept a certain level of defects is inappropriate, is unethical. We can't accept that. We will try to prove. 4, I will make frequent small releases. I will not impede progress. One of the best ways for a software developer to slow everybody else down is to check out a module and hold it for 3 weeks, and then cause a big merge. The best way for a software developer to impede his associates is to hold the code tight and not let anyone else see it. I want you to release the code frequently. I want you to release the code daily, maybe several times a day, so that other people can see what you have done and integrate the work that you have done. I don't want anybody holding on to it and saying, wait till I'm done, because everybody else is going to have to wait a long time. Smallness in release is how we make progress fast. 5, I will fearlessly and relentlessly improve the code at every opportunity. I will never make the code worse. This is an interesting one. How many of you have been significantly slowed down by bad code? Okay, this is almost everybody. I see one person with their hand down. They're either not a programmer or they're lying. Because, of course, we have all been badly slowed down by bad code. Why did you write it? If you know the bad code is going to slow you down, why did you write it? Or more importantly, why did you allow it to stay? You see the bad code. Why do you allow it to stay? So let me set up a scenario for you. You are sitting at your terminal or your laptop or whatever the heck it is you program on now, and you're scrolling through some code on your screen, and all of a sudden you look at something and you say, oh man, that is awful code. I should clean it. And the very next thought in your mind is, I'm not touching it. Because you know if you touch it, you will break it. And if you break it, it becomes yours. And so you walk away. Not me. I'm not going to be the one to touch that code. And so the code must rot. Because no one will clean it. It's too scary to clean it. And the code must rot and get worse and worse over time. And no one will clean it. I want you to think about how wildly irresponsible that is. To be so afraid of this thing that you have created that you are not willing to do the one thing that might help it. Clean it. Of course, the problem is fear. How do you deal with the fear? How do you eliminate the fear? How can you not be afraid to change the code? Well, remember I mentioned that interesting proof, the quick, sure, repeatable proof? If you have a suite of tests, and you believe that suite of tests, and you can run that suite of tests, then when you see that bad code on your screen, your next thought is, oh, I think I'll change the name of that variable. And you'll run the tests. Oh, they passed, good. That function's a little too large. I think I'll split it in half. Run the tests. Ooh, passed, good. Okay. Ooh, this little fragment of a function that I just created, that really belongs in that class over there. Run the tests. Oop, they failed. Put it back. Run the tests. Ah, pass. Ooh, I see what I did wrong. Okay, move it over there. Run the tests. If you have the tests, if you have a test suite that you trust with your life, you can clean the code. And that is how you fearlessly and relentlessly improve the code at every opportunity. 6, I will keep productivity, my own and my team's, high. I will do nothing that decreases that productivity. I will not damage the code. I will not make the code worse. I will keep productivity high. I will not check out the code for long periods of time. I will keep productivity high. I will not create a suite of tests that takes hours to run. That will reduce productivity. I will make it important to keep the tests running fast. That will enhance productivity. I will do nothing that decreases productivity. 7, there's only 9. 7, I will continuously ensure that others can cover for me and that I can cover for them. Imagine a team, a sports team, moving the ball down the field against their opponents. And one of the team members goes down, trips, falls, injured. What do the other team members do? They cover the hole. They keep the ball moving downfield until the flag is thrown, if the flag gets thrown. They cover the hole. They cover for that player. In order to cover for a player that's gone down, you have to know how to cover that position. If we are a team, if we work on teams, and we love to use the word team, but if we are on teams, then we cover for each other. Bob is the database guy. Bob gets sick. Somebody's got to be able to do the database work. If nobody else can do the database work because Bob's the only database guy, then we do not have a team. And I noticed that I put the onus upon you. I will continuously ensure that others can cover for me. It is your responsibility to make sure that somebody else knows your job, somebody else knows your work, somebody else can cover for you if you go down. It is your responsibility to the team to make sure that you are not the single essential component. How do you make sure that someone can cover for you? What is the best way to teach someone what you are doing and where your code lives and where your tests live and what the structure of your stuff is? What is the best way to make sure that someone can cover for you? I suggest perhaps that there is a discipline that people have called pair programming that might help. 8, I will produce estimates that are honest, both in magnitude and precision. I will not make promises without certainty. What is the most honest estimate you can give? I heard it out there. 3 little words. I don't know. How long is this going to take you? I don't know. Now, that is entirely honest. It is also not very useful. So what we need to do is make it a bit more useful without sacrificing the honesty, which is, I don't know. So what we do is we put bounds around it. We outline our uncertainty. And we can do that through a number of techniques. I will describe one for you. Someone says, all right, how long is this going to take you? And you think, all right, well, look, if everything goes perfectly, and I mean perfectly, this will take me 5 days. If things go as they normally do, it'll take me 10 days. And if everything goes wrong, short of nuclear war, it's going to take me 25 days. And with that, you have drawn a nice little curve around your uncertainty. You have bounded your certainty. You have described your uncertainty. It is completely fair and completely honest. And the people you relate that to are not going to like it because they want certainty. Who doesn't? And it's perfectly fair for your manager to come back and say, oh man, I can't deal with that uncertainty. Perfectly fair. There may not be anything he can do about it, or she, but it's perfectly fair. And it's perfectly fair for a manager to put pressure on you. Say, now wait, what about this? What about that? Can't you do it this way? Can't you do it that way? Isn't there some way we can make this more certain? And of course, you should listen to all of that. But you should never make a promise without certainty. Because if you make a promise without certainty, you are lying. If you say, okay, I'll get it done by Tuesday, and you don't know you can get it done by Tuesday, you have to get it done by Tuesday without fail, or you're lying. Now, the kind of pressure that you can be put under here is many, many different forms. But one of the most obvious is this one. And watch out for this one because it's very, very tricky. You will say, oh, I think somewhere between 5 and 25 days. And that no one's going to like that, right? And they might come back to you and say, well, I need it by Friday. And you say, well, I can't promise that. And then they might say something like this. Will you at least try? And the answer to that is, how dare you accuse me of not trying? I have been trying this entire time. I will continue to try this entire time. It is insulting to me that you have suggested that I am not trying. You probably don't want to use those words, but that should be the reaction in your mind because it's the fundamental truth. You have been trying. What? I mean, is there some like extra capacity that you haven't been giving? Have you been holding some capacity back? Are there magic beans in your pocket with which you can change reality? Of course you have been trying. You provided the best knowledge you could, and then someone wants you to try. And the answer is no, I am trying. I cannot change the reality of this situation. I'm sorry, manager, whoever you are, but you'd better deal with the fact that I am uncertain and I cannot narrow my uncertainty down. Now, you don't want to get waltzing around and drawing normal curves on all the boards and say, look at how uncertain I am. That's not a good idea, and you should always be hunting for ways to narrow the curve and working with people and so forth. But here is the fundamental truth of why you were hired. You were hired for your ability to say no, because you are the only people who know when the answer is no. And if you then say yes to something when you know the answer is no, you doom the project to failure, and you doom your team members, and you doom your company. Last one, and it's a short one. 9. I will never stop learning and improving my craft. I will never stop learning and improving my craft. To some extent, this is unfortunate because much of what we have to learn is repetitious. Anybody learning a new language like Swift? Anybody doing Swift or how about Go? Anybody learning Go or Dart? Anybody learning Dart? All right? Anything new in these languages? What? Rust. Yeah, you're learning Rust. Good. Anything new in these languages? Any new concept in any of these languages that has not been tried before? And the answer to that is no. There have been no new language concepts probably for 30 years. But we keep on inventing new language after new language after new language. Why? Why do we keep on inventing new language after? And the reason is very simple. We hate the language we're working in. And we want some new language out there. There's got to be some new language out there that's better than the one I'm working in. And the answer is there's probably not a new language out there that's better than the one you're working in because there hasn't really been a new language in the last 30 years. They're just rehashes of all the same old stuff. So that's one of the unfortunate sides of why we have to keep learning, but we have to keep on learning because we will have to use those new languages, and we will have to use the new frameworks, and we will have to use the new processes, and you have to keep learning them all the time. Otherwise, you fall behind. And you, as a software developer, you don't want to fall behind because then the only option for you is to go into management. When do you do this learning? When do professionals learn? Not on the job. It is not your employer's responsibility to groom your career. It is your responsibility to groom your career. You take responsibility for your career. You learn at home. You learn on Saturdays and in the evenings. You read, you play, you get your laptop out, you learn a new language. You give 40 hours a week or whatever the hour count is that you're supposed to give to your employer, but you go home and you spend another few hours because that's what all professionals do. Professionals spend much more than 40 hours a week on their career. It's just the truth of the matter. You may not like it, but that's the way it is. And with that, I think I'm going to end my talk. Thank you all for your attention.